Homework 11, Polynomial Functions, Video 5. Another example of end behavior. And at the end of this example, I'm going to show you a gimmick for determining end behavior without necessarily remembering that 2x2 chart in the previous video. But let's take a look at this example first. Determine the end behavior of r of x equals the quantity 1 minus x squared times the quantity 2 minus x squared squared. I'm going to change this 2 in the parentheses to a 4 because I think I'm going to recycle this function later. Let me write it off to the side where I write my notes that you can't see, but I refer to during these videos. All right, if we want to know the end behavior, then we need to know the leading term. So just like before when we were trying to determine the degree and leading coefficient of a polynomial function that was factored, we need to not necessarily multiply it all out, but just find the leading term. And remember, to find the leading term in a polynomial that's already factored, you just have to multiply the leading terms of each factor. So let's write out all the factors, 1 minus x squared, and we will write the 4 minus x squared twice. And in all three of these factors, the leading term is the second term. The highest power in the first factor is negative x squared, the highest power in the second factor is negative x squared, and the highest power in the third factor is negative x squared. Which means if we multiply all three negative x squareds together, that would give us the leading term. I'm going to go ahead and write plus and ellipses, indicating that there is more that I'm not writing, but I don't need to know. So what do we get when we multiply negative x squared times itself 3 times? Well, let's hash out the negatives first. Negative times negative is positive, but times a third negative is negative. And there's a rule that says when you multiply a letter repeatedly, you can just add the exponents. So 2 plus 2 plus 2 means that the new exponent is going to be 6. So the leading term is negative x to the 6th power. And now we can analyze it. The degree is even. The leading coefficient is negative. And if you were to look at the table, the conclusion that we would draw is what? Both ends fall. So if you're determining end behavior, but your function is already factored, you need to recover the leading term by multiplying the leading terms in all of the factors together. To give a little more substance to this video, I want to conclude it with a gimmick. Now, as I mentioned, because your test is going to be with notes, you don't have to memorize anything. You just have to understand what the question is asking. But there is a way to determine end behavior quickly without the need for a table. So here's the gimmick. When the degree is even, either both ends rise or both ends fall.